So in this set of problems, we have two classic problems which demonstrate the use of derivatives to find rates of change. All right, so let's look at problem number one. Is the particle moving from left to right or from right to left? So we're trying to find the rate of change, and if we're dealing with horizontal motion, we know that if the velocity is positive, the particle is moving to the right, and if the velocity is negative, the particle is moving to the left. So in order to find velocity, we want to take the derivative of the position function. All right, so the derivative is 6t squared minus 6t minus 12. All right, and we want to find the velocity at 1. So if we plug 1 in, we get 6 times 1 squared minus 6 times 1 minus 12, which is equal to 6 minus 12, which is negative 12. So since this number is negative, we know that the particle is moving to the left. All right, so that's question number one. How about question number two? Is the particle speeding up or slowing down at time t equals 1? So hopefully you saw the video, and the video says that if the velocity and acceleration have the same sign, meaning they're both negative or they're both positive, then that means the particle is speeding up. And if they have opposite signs, the particle is slowing down. So let's see. We already have the velocity function. The velocity is given by this. So the acceleration is actually equal to the derivative of the velocity, right? It's the change in the velocity is the acceleration, which is also equal to the second derivative of the position. So we take the derivative of this and we get 12t minus 6. All right, and so let's go ahead and find the acceleration at time 1. And so if I take the acceleration at time 1, I get positive 6. And so this has a positive sign, and this has a negative sign. The velocity is negative, and the acceleration is positive. So that means that the particle is actually slowing down at time t equals 1. All right, so now we're on problem number 3, which is determine the time intervals when the object is slowing down or speeding up. And we already said that when the velocity and the acceleration have different signs, that means that the object is slowing down. And when they have the same signs, both are positive or both are negative, then that means they're speeding up. So let's start by finding out the intervals where the velocity is positive and where it's negative, and then we will do the same for the acceleration. So the velocity function is given by 6t squared minus 6t minus 12, and we can set that equal to 0 to find out maybe when it's changing from positive to negative and then negative to positive. So let's go ahead and set this equal to 0. And I'm going to factor out a 6. That leaves us with 6t, or t squared, minus t minus 2. And then I'm going to factor that. So I get 6 times t minus 2 times t plus 1 equals 0. And we know that if the product of three things equals 0, that either this is 0 or this is 0 or both. So we know that t equals 2. Or t equals negative 1. And we know that t can't equal negative 1 because we have a negative time. So t equals 2 is the only number we're concerned with. So I'm going to draw a number line here. And here's t equals 2. And I'm going to see what the particle is doing between 0 seconds and 2 seconds. So the way I can do that is I can pick a number between 0 and 2. Let's go ahead and pick, let's pick 1. And if I plug 1 into my velocity function, so if I find v of 1, I'm trying to find out what kind of a value I have. So if I plug 1 in here, I'm going to get 6 minus 6, which is 0, and then minus 12, which is a negative value, negative 12. So we know that the velocity is negative. or the object is going left from 0 to 2 seconds. And then we're trying to figure out what happens after 2 seconds. So at 3 seconds, let's try that. And so if we plug 3 in, we're going to get 6 times 9, which is 54, and then minus 18 and 12. It doesn't really matter what the value is, we just know that it's positive. Okay, so we know that it's going right at this point. So for any time after 2 seconds, it's going right. And we know it's not going to turn around again because there's no other value where it's, no other place where it's going to be 0. Remember, we set this equal to 0 over here, and we found the only time that it would be 0 is at 2 seconds. So we know it won't turn around again. So that's where my velocity, that's the direction from 0 to 2 seconds, it's going negative or left, and then at 2 seconds it turns around, it goes positive, and it's positive from there on out. So now let's look at acceleration, and we have the acceleration function, 12t minus 6, and let's set that equal to 0 to find out when acceleration changes from positive to negative. So we get 12t minus 6 equals 0, which means 12t equals 6, and t equals 1/2. So let's put 1/2 on this. So let's say this is 0. And so let's pick 1/2 here. And so I'm going to check acceleration now. And so I'm going to pick a value between 0 and 1/2, and I'm going to plug it into the acceleration function. So let's go ahead and pick the value of 1/4. So if I take a of 1/4, I'm going to get 12 times 1/4, which is 3, and then minus 6, that gives me a negative 3. So the acceleration is negative here between 0 and 1/2. Let's try a value between 1/2 and 2. Let's try 1. So if I take a of 1, I get 12 times 1 minus 6, which is positive 6. So it's positive between 1/2 and 2. And now let's pick a value bigger than 2. So if I take a of 2, I get 12 times 2 is, or excuse me, let's try 3. If I do 3, I get 12 times 3, which is 36, minus 6, which is still a positive value. All right, so let's find out when these match up. We have to have the velocity, which is up above the number line, and the acceleration matching up in sign. So we know between 0 and 1/2 we have a negative acceleration, and we also have a negative velocity. All right, so between 0 and 1/2 seconds, the object is speeding up. So between 0 and 1/2 seconds, the object is speeding up. Then between 1/2 seconds and 2, notice that the signs don't agree. So then it's slowing down between 1/2 seconds and 2 seconds. And then again, it's speeding up after 2 seconds because these are both positive. They agree in sign. So we know it's speeding up between 0 and 1/2 seconds, and then after 2 seconds. T between 0 and 1/2 seconds, it's going to be speeding up. And also between, and then t greater than 2. All right, and then between 1/2 and 2 seconds, it's going to be slowing down. All right, so in this next problem, we have a potato being launched vertically upward with an initial velocity of 100 feet per second from the top of a building. And the distance in feet that the potato travels from the ground after t seconds is given by s of t equals negative 16t squared plus 100t plus 85. So they're asking, what is the height of the building? So I like to draw a picture when I start these problems just so I can visualize what's going on. So we have this building, and there's a potato being launched up in the air, and then it comes back down. And we don't know how high it goes, but it comes back down. And we know that the position function is s of t equals negative 16t squared plus 100t plus 85. All right. So what do we know about the potato at time t equals 0? All right. What do we know about the position of the potato at time t equals 0? Well, we know that at the start, the position is going to be all right. So at time t equals 0, we have a position of 85. All right. So that means that the height of the building is 85 feet. Right? So we've answered the first question. This is 85 feet. All right. Now we want to find the velocity of the potato after 0.5 seconds and 5.75 seconds. So in order to find velocity, we need to take the derivative. So let's go ahead and do that. Velocity equals negative 32t plus 100. That's the velocity. I've taken the derivative of the position function. This is s prime of t, right? Equals negative 32t plus 100. So if I find the velocity after 0.5 seconds, I'm going to get negative 32 times 0.5 plus 100. So that gives me negative 16 plus 100 is going to be 84, I believe. So the velocity at 0.5 seconds is 84, and we want our units, so we say feet per second. And then the velocity at 5.75 is going to be negative 32 times 5.75 plus 100, which is equal to negative 84 feet per second. All right, so we have at 0.5, it's going 84 feet per second, and at 5.75, it's going at negative 84 feet per second. So why do you think that there's a change in the sign of the velocity between 0.5 seconds and 5.5 seconds? All right, well, we know that if there's a positive velocity, it's going up, and a negative velocity, it means it's going down. So somewhere between 0.5 and 5.75, it reached the top of its height and then started coming back down. All right, so let's try to find out when the potato reached its maximum height. All right, so how would we do that? How would we find out when the potato reaches its maximum height? Well, what happens at the top here? If the velocity is positive going up and negative going down, if something goes from positive to negative, what number does it have to go through? It has to go through 0, right? So we want the velocity, we want to find when the velocity is 0 because that'll tell us when it goes from positive to negative. So let's set the velocity function equal to 0. And so let's solve for t, and that will tell us when that happened. And I get 3.125. And that's the units for that is seconds. All right, so at 3.125 seconds, it reaches its maximum height. All right, so now it's asking find the acceleration of the potato at 0.5 seconds and 1.5 seconds. All right, so velocity is this function. To find acceleration, we would take the derivative of that, right? It's the rate of change of velocity. So we just get negative 32. All right. So the acceleration at 0.5 seconds, there's no place to plug that in for t, so the acceleration is negative 32. And when we talk about acceleration, the unit is feet per second squared. And the acceleration at 1.5 seconds is also negative 32 feet per second squared. So the acceleration is the same at 0.5 seconds and 1.5 seconds. Now we want to determine how long the potato is in the air. So what do we know? How can we determine how long the potato is in the air? What do we know about it when it hits the ground? Well, the one thing that we can be sure of is that when it hits the ground, the position is going to be 0, right? So if we set the position equal to 0, and solve for t, we can find out when the potato is going to hit the ground. So let's go ahead and do that. It looks like it's going to be difficult to factor, so I'm going to use the quadratic formula, and hopefully everyone remembers the quadratic. So we're going to do negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So and that's going to give us the t values where it equals 0. So let's go ahead and solve this. I'm going to take a moment to put this into my calculator, and then I'll get back to you with the answer. All right, so I got the answers negative 7.58 and 7.008, I believe. And since time can't be negative, this is going to be our answer, 7.008. So that's how long the potato is in the air. And then determining the velocity of the potato upon hitting the ground. Now that we know the time that it takes for the potato to reach the ground, we can now plug that into our velocity function to find out with what velocity it hits the ground. So if I take velocity, or v, of 7.008, I'm going to do negative 32 times 7.008 plus 100, and we get equals negative 124.256. All right, and that's going to be in feet per second. So the potato hits the ground at a velocity of negative 124.256 feet per second.